So in this video, we are going to solve some limit questions. The first question on the board I have is, you should find the limit as u approaches 5 for u to the power 2 minus 25 over u minus 5. So for this question, the method I'm going to apply here is L'Hopital's rule. When I'm done, then I'll apply the method of transformation also. So you see that for this question, if you are to put 5 in here directly, you will get 0 over 0. Okay, so this tells you that it is indeterminate. You can't determine the limit because you don't actually know the answer for 0 over 0. Okay, so for us to be able to determine this limit, you have to break this down so that it will be easy for us to get our limit. So L'Hopital's rule says that for us to find the limit of any quotient which is indeterminate, we should differentiate what you have on the top and then differentiate what you have on the down. So I'm going to do, the limit will now become as u approaches 5. Okay, will now become, I'm differentiating what I have on top, that will be 2u, okay, minus 0 all over 1 minus 0. So at the end, my limit as u approaches 5 becomes 2u. Okay, so then I'll have 2 times 5, which will then give me 10. So that will be my limit. So that's for the L'Hopital's rule. Okay, so now let's look at how to apply the transformation also. So looking at the top here, I have u to the power 2 minus 25. Okay, so I can write this as u to the power 2 minus 5 to the power 2. Then I now have difference of squares. So this will give me u plus 5, and then u minus 5. Okay, so this is what I'm going to use now. So I now have the limit as u approaches 5 to be u plus 5 u minus 5, okay, all over u minus 5. Okay, so now I can cancel out this, then I now have my limit as u approaches 5 to be u plus 5, which will be equal to 5 plus 5, and then I have 10. So this will be my limit. So this is how to solve such questions. So now let's move on to the next question. Okay, so for the next question, I have here that we should find the limit as x approaches 0 for root of x plus 3 minus root of 3 all on x. Okay, so you can apply L'Hopital's rule here. I think that will be the easiest way to do this question. So let's look at this. So I'm going to rewrite what I have here. So I now have the limit to be the limit as x approaches 0, okay, to be x plus 3 to the power 1 over 2, okay, minus 3 to the power 1 over 2 all over x. Okay, so what I've written here is the same thing I have on top. Okay, x plus 3 to the power half is the same as the square root, and then 3 to the power half the same as the square root, and I still have this one here. Okay, so from here I'm going to apply the power rule here. Okay, since you're able to write it in this way, so the limit as x approaches 0 now becomes, we bring this half in front, so I have 1 over 2 into brackets x plus 3 to the power minus half, because you subtract 1 from half, so you get minus half, and then this will give us 0 because it's a constant. 3 to the power half is a constant. Okay, so all divided by the derivative of x, which is what, 1. So at the end I'll have the limit as x approaches 0 to be 1 over 2 into bracket x plus 3 to the power negative half. Okay, so you can leave your answer like this, or you can go ahead and then simplify it. So you can now have the limit as x approaches 0 to be 1 over 2 into bracket x plus 3 to the power half. Okay, since I wrote it this way, that's how come I ignore the negative. And x plus 3 to the power half can be written as 1 over, let me continue from this side. You can write this as the limit as x approaches 0 to be 1 over 2 root of x plus 3. Okay, so now from here you can fix in our 0, so that will be 1 over 2 root of 0 plus 3, and this will give me 1 over 2 square root of 3. So this will be our answer. So you can go ahead and then try the transformation method for this one too. So with that one, you have to multiply by the derivative, by the conjugate of the one you have on top. So you're going to multiply by the conjugate of what you have on top, and then you simplify it, and that will give you your answer. So you can go ahead and then try that. Okay, so let's move on to the next question. Okay, so in this question, it said we should find the limit as x approaches infinity from the right side. Okay, x approaches infinity from the right side. So that will be for this function here. Okay, so the easiest way for us to do is to prove whether the answer will be what, positive infinity or what will be negative infinity. So let's look at that. So I now have the limit as x approaches positive infinity. Okay, for this expression. So I want to prove whether the limit of this will be what will give me a positive infinity or negative infinity answer, because it is out approaching infinity. So what I'm going to do here is that I'm going to factor out the highest power. Okay, I'm going to factor out the highest power, which is what, x to the power 11. So I now have the function to be x to the power 11 to bracket 2. Okay, all right, minus 5 over, okay, or minus 5 over, okay, so 11 minus 6 will be 5, so that minus 5x, 5 over x to the power 5, okay, plus 3, okay, over x to the power 2. So x to the power 2, if I subtract 2 from 11, I'll get 9, so that will be over x to the power 9, plus 1 doesn't have any variable, so it will just be 1 over what, x to the power 11. Okay, so when I do this, when I multiply this x to the power 11 by this, I still get what I have here. So I just transformed it into this way so that it will be easy for us to prove. Okay, so now looking at this, if I'm to find the limit of what we have here, okay, 2 minus 5 over x to the power 5 plus 3 over x to the power 9 plus 1 over x to the power 11. If I'm to find the limit for just this, you see that the limit will be what? Approaching 2. The limit will be approaching 2. This is because this value here will be what? 5 over what? Infinity to the power 5. And you know, this will be 0. This one will be what? 3 over infinity to the power 9. This will also be what? 0. And then 1 over infinity to the power 11 will also be what? 0. And at the end, I have just the 2 here. Okay. And then when I find the limit of infinity to the power 11, this one also gives me what? Positive infinity. So at the end, I have positive infinity times 2, which is also what? Infinity. So therefore, our answer will be what? Positive infinity. So that's all for this video. Thank you for watching. Okay, so this is the next question I have on the board. So if in this question you are going to apply L'Hopital's rule, which says you can differentiate what you have on top and then differentiate what you have on down if it is in the quotient form. So I now have my limit as x approaches 1 to be, I'm going to differentiate what I have on top. So that will be 4x cubed plus 9x squared minus 13. Okay, this will be 26x minus 27 all divided by 2x plus 3. So I've differentiated it now. So from here I can put my 1 here to get my answer. So I now have 4 into brackets 1 to the power 3 plus 9 into brackets 1 to the power 2 minus 26 into brackets 1. Okay, all over okay, I forgot this. I almost forgot this. Minus 27. Okay, this one is also here. So all over 2 into brackets 1 plus 3. So this will now give me 4 plus 9 minus 26 minus 27 all over 5. Okay, so when I do this, let's see what you get. So 4 plus 9 minus 26 minus 27. So this gives me minus 40 on 5. So minus 40 on 5, I'll then have my answer to be negative 8. So this will be my limit. Okay.